Factoring by grouping is a technique for factoring polynomials with an even number of terms. Let's begin by considering some preliminary examples. Our instructions are to factor, which means to write as a product. To factor 3x squared plus 12x, we first note that each term has a common factor of 3x. When we undistribute this factor of 3x, our remaining factor is x plus 4. Similarly, to factor bx plus 4b, we recognize a common factor of b. We undistribute the common factor of b to get b times the quantity x plus 4. To factor x times x minus 3 plus 4 times x minus 3, it won't help to start distributing. We want to write this expression as a product. Note the common factor of x minus 3 in both terms. We can factor out x minus 3, and the remaining factor is again x plus 4. In the last example, we have a common factor of 2x plus 7 that can be factored out. Once again, our remaining factor is x plus 4. Look carefully at these examples and note the similarities. Now let's consider how factoring by grouping works. To factor a 4-term polynomial, first, factor out any common factor from all 4 terms. Then group the terms in pairs. In each pair, factor out the GCD of that pair of terms. Finally, factor out any common binomial factor that results. Let's consider 4 examples. First, we want to factor 5x cubed minus x squared plus 15x minus 3. The 4 terms don't have any common factors. We group the terms in pairs by inserting parentheses. The first pair of terms has a common factor of x squared, and the second pair has a common factor of 3. We factor these out. Then notice a common binomial factor of 5x minus 1. When we factor out 5x minus 1, the other factor is x squared plus 3. Let's look at another example. Now, we want to factor 2x cubed plus 8x squared plus x plus 4. Again, there is no factor that all 4 terms have in common. We group the terms in pairs by inserting parentheses. The first pair of terms has a common factor of 2x squared, and the second pair has a common factor of 1. We factor these out and explicitly insert the factor of 1. Now notice the common factor of x plus 4 in both terms. Factoring out the x plus 4 leaves another factor of 2x squared plus 1. For our third example, we want to factor 3x cubed plus 18x squared minus 5x minus 30. This time, we have to be careful when inserting parentheses for grouping because the coefficient of the third term is negative. The first pair of terms has a common factor of 3x squared, and the second pair has a common factor of negative 5. We need to be careful factoring out the negative 5. Now we can undistribute the common binomial factor of x plus 6, leaving a second factor of 3x squared minus 5. Let's consider a final example. We want to factor 8x to the fourth minus 28x cubed minus 6x plus 21. Again, we have to be careful with the negative coefficient on the third term. We insert parentheses to group the terms in pairs. The first pair of terms has a common factor of 4x cubed. The second pair has a common factor of 3, but we will factor out a negative 3 since the first term of the second pair is negative. Typically, when the leading coefficient is negative, we like to factor out the negative. So we get 4x cubed times 2x minus 7 minus 3 times 2x minus 7. Notice the common binomial factor of 2x minus 7. When we factor this out, our remaining factor is 4x cubed minus 3. Even though factoring by grouping requires an even number of terms, this technique will be useful when factoring quadratic trinomials.